class, today we'll wrap up section 5.4, which is analyzing graphs of polynomial functions. Today what we're going to be looking for are our maximum and minimum points on a quadratic function. So, to start with, maximum and minimum points. A quadratic function has either a maximum or a minimum point on its graph. For higher degree polynomial functions, you can find what are called inflection points which represent the relative maximum or minimum points. And what an inflection point is, it's when the graph makes a turn. So we're climbing up, we hit a peak here, and then we start going down. That's called an inflection point. Or here, we're going down, we make a turn, and we head up. That's an inflection point. Those are where maximum and minimum values occur. In this case, we have this function, x cubed plus 6x squared minus 3. You can plot a table of values. So you plug in your values for x, you get your output, your values for y, and you can see that from this table that there's a relative maximum at negative 429, and then, so that's the highest number here, and then the smallest number is right here at negative 3. It also shows us that there's a 0 between these two values, and that is because the sign changes. The f of x sign changes, so that means a 0 has occurred. So I need for you to make one change on your notes. This should read relative maximum at x equals negative 4. So we go to negative 4, and that's where there's a relative maximum. The relative minimum is when x is 0. So to make it be confusing, you may want to say what the y value is, but when you're referring to the relative maximum and minimum, you're referring to what is the x value where that maximum or minimum occurs. Okay, so I'm going to give you the values that are going to go in this function, 2x cubed plus x squared minus 3x, if we were to plug in these numbers for x. The first one would be about negative 4.4. That's when x is negative 1.9. When x is negative 1, f of x is 2. When x is 0, f of x is 0. When x is 0.5, f of x is negative 1. When x is 1, f of x is 0. And when x is 1.5, f of x is 4.5. Okay? So we can see, well, let's just graph it first, and then we can verify with the table. So if you're going to plot negative 1.9, negative 4.4, what we're going to do is go about out to negative 2, and then go down 1, 2, 3, 4. 4.4 would be somewhere around right here. Negative 1 has a point at 2. Then we have a point at 0, 0. At 0.5, negative 1. At 1, 0. And then at 1.5 and 4.5. So 1, 2, 3, 4.5. Now we have to look at what our end behavior is. This is an odd function with a positive lead coefficient. So that means that our ends are going to point down to the left and up to the right. So this end is going down, this end is going up. So we want to connect our points. So we see we turn around here, we dip back down, and then we shoot up like so. Okay, so you can see that we have a relative maximum at x equals negative 1, let's see, I may have graphed it wrong. I didn't graph it wrong. Oh, I'm sorry. I was reading my, I failed to plot a point. I failed to plot this point right here. No, oh no, I didn't. I'm sorry. I'm getting myself confused. I did plot this point. This is the highest point that the graph reaches where it has an inflection point. Okay, so when it changes directions, so you could call it a peak and a valley if you wanted to. So this peak is when x is at -1, and this valley is when x was at 0.5. Okay, so even though this is the highest number on our graph, we're not turning around after that point. When we hit 2, or when we hit x is -1, we hit the 2, and then you can see that as x gets bigger, y is getting smaller, so it's turning around. Then when we hit 0.5 for x, that's when y is -1, the graph turns back around, that's an inflection point, and heads the opposite way. So these are our relative maximum and minimum, and again, they're referred to by what is x at that point. Let's try one more example. So on our next example, we're going to plug in -1.8 into the function. 2x cubed minus 3x plus 2 would be -4.3. If we plug in -1, we get 3. If we plug in 0, we get 2. If we plug in 1, we get 1. And if we plug in 2, we get 12. And that, again, is plugging it into, I don't know if you can see if it's because of my Christmas ornament, 2x cubed minus 3x plus 2. That's the function we're plugging into. So we'll try to graph, approximate where -1.8, -4.3 is. Let's just say this is about -1.8 and -4.3. Let's just say it's about right here. Then we have a point at -1, positive 1, 2, 3. We have a point at 0, 2, at 1, 1, and at 2, 12, which would be off our graph up here. So we want to also look at our end behavior. We have our odd power, but we have a positive coefficient. So again, we're going to point down on the left, up on the right. So let's make this one up. Let's make this one down, and then let's connect our points. So we go up, we come back down, and we shoot back up. So hopefully you can see that the relative maximum is when x is -1, and the relative minimum is when x is 1. hope these make sense. They're kind of fun to graph. Let me know if you have any questions or problems, and I will talk to you next time. Have a great day.